Hello everybody, in this video we are going to look at conditional and biconditional operations with truth tables. So we're going to be adding conditional and biconditional operations into our truth tables to tell if a statement is valid. So a conditional statement is where one implies the other. So P in this case implies Q. So for example, if it is raining, then there are clouds in the sky. It's a conditional statement because if it's true that it's raining, then it's also true that there's clouds in the sky. But it doesn't necessarily work the other way. Just because there's clouds in the sky doesn't mean it's raining. Okay, so it's only implied in one direction. So the truth table for this, if you remember our P and Q, we do true, true, false, false, true, false, true, false to find all our combinations of P and Q. In order to figure out P implies Q, what we're looking at is anywhere that P is true, Q must also be true. If P is false, then Q can be either true or false, okay? So if it is raining, then there has to be clouds in the sky. But if it's not raining, there may or may not be clouds, okay? So if it is raining, then there is clouds in the sky. Yes, that's true. If it is raining, there's not clouds in the sky. That can't happen. But if it's not raining, then there can or can't be clouds in the sky. So basically, the only one here that is false is if P is true, Q must also be true. Okay? So T is true, TF is false, but if P is false, then Q can be true or false. So for example, if I graduated Niagara College's CPA program, then I passed Math 1205. So if you graduated the program, you must have passed Math 1205. If you pass Math 1205, it doesn't necessarily mean that you graduated from the program. Okay, so our two statements here is I graduated from the program and I passed Math 1205. Again, if this is true, then this must also be true. If you graduated, you must also have passed. If you graduated and you did not pass, then that's false. But if you don't graduate, then you could have or could have not have passed this class. Another example, if you can access the computer lab on campus, then you are a CPA student or you're not in your first year. So our statements here is you can access the computer lab on campus, you are a CPA student, or you are in first year. Those are three statements that are within this sentence. And if I'm writing this in symbolic logic, it's going to look like this. If you can access the computer lab on campus, then you are a CPA student or you're not in first year. Okay, so the implied comes from where the then is. If you can access computer lab, then you are a CPA student or you're not in your first year. Okay, so if we want to create a truth table for this, we're going to do our P, Q, and R. Okay, those are our three statements. So we want to come up with a combination of all of these. So I'm going to do 4 truths, 4 falses, true, true, false, false, true, true, false, false, and then true, false, true, false, true, false, true, false. That pattern helps us come up with all the different combinations of P, Q, and R we can have. I'm then going to look through this and kind of break it down into chunks. So I like to do my nots first. So not R, I'm going to do here. Basically going to take everything in here and change it into the opposite. So if it was true, it's going to become false. If it was false, it's going to become true. Then I can look at Q or not R. So I'm looking at this column and this column, and if either of them are true, then it is true. So true, true, neither of them are true, so it's false. True, 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 neither of them are true, so it's false. True. Okay, so this part now gets this. I'm now going to see if P implies this column. So I'm looking at this column, and I'm making sure that wherever there's a true in this column, there has to be a true in this column. If there's a false here, then it doesn't matter what's in this column. Okay, so true and true is true, true and true is true, true and false is false, true and true is true. These are all falses, so it doesn't matter what's in this column, they're all true. Okay, so let's construct a truth table for the following. P implies Q and Q implies P. So I'm first going to set up my P and Q. Now I'm going to look at P implies Q. And now I'm going to go backwards and see if Q implies P. So wherever there's a true here, there has to be a true here. Okay, and then I'm going to look at and. So I'm looking at these two columns and I want to see where they're both true. Okay, so they have to be the same, this and this. So true, true, true. Nope, nope. Yes, true. So true, false, false, true. Okay, biconditional is when P, if and only if Q. So P is true if and only if Q is true. Okay, so for example, you will be paid next Friday if and only if you submit your timesheet today. It's a biconditional statement because they have a co-relationship. So if you submit your timesheet, you will be paid. You'll be paid if you submit your timesheet. So both have to have the same truth value. So if you submit your timesheet, you will be paid. If you don't submit your timesheet, you will not be paid. Okay, so unlike the conditional statement here, where I'm looking if this is true, then this must also be true. But if this is false, it can be either true or false. For biconditional, they have to have the same. So here's my P and Q. They both have to be true or they both have to be false in order to be true. So another example, you can take a flight if and only if you buy a ticket. So our statements are you can take a flight, you can buy a ticket. So therefore, if you take a flight, you bought a ticket. You can't take a flight if you didn't buy a ticket. If you bought a ticket, you're going to take the flight, so that's not true. And if you didn't buy a ticket, you're not going to take the flight. Okay, so let's construct this truth table. I know they get more and more complex, but it's about breaking it down into small chunks. So the first thing I'm going to do is I have P's and Q's, so I'm going to set up my P's and Q's. I then have some nots in there, so I'm going to look at my not Q, and from there I'm just going to build up this first bracket. So I have a not Q, and this is P and not Q. So I'm going to look at the first column here and this column and see if they're both true or both the same. So I get true and false is false, true and true is true, false and false is false, and false and true is false. So I want to look and see that they're both true. So the only one there is this one. So then I'm going to find the not of this bracket so that I have this whole side of our or symbol. So I'm just going to change all of these. Then I'm going to find this bracket, my biconditional statement. So I'm looking at the P and Q and I'm seeing if where they have the same truth value. So true and true is true. These are all different, so they're false. This is false and false is true. Okay, so now I have both sides of my or statement. So I'm going to look at these two columns and see where either of them is true. I have true, false, true, true. So this is the only one where there is no true value there. Okay, so your columns here might be slightly different than mine depending on how you break it down. As long as your final column here is the same, then that's perfectly fine if you broke it down in a different way than I did. But you are going to want to break it down into smaller chunks and kind of build up to either side of our and or statements. Okay, an argument is a set of statements. All of the statements are called the hypothesis except for the final statement, which is the conclusion. And what you're going to do is look at if you were to combine all of the hypotheses together, do they imply the conclusion? What that means is at the end, if it implies the conclusion, then that final column should all be true. If there's any false there, then those hypotheses do not imply that conclusion. So for example, here's two hypotheses, P and not Q, and I want to test if they imply that P implies Q. So what I'm going to do is I'm going to combine P and not Q implies P implies Q. So you're going to combine your hypothesis with an and symbol, and those together, so that's why I have brackets around them because they all have to combine together first, and I'm going to see if they imply my conclusion, which is P implies Q. Okay? Once I have that statement written from the hypothesis and conclusion, I'm going to use a truth table. So again, I have a P and a Q. I'm going to find my not Q in there, and then I can find my P and not Q. I can find my P implies Q, and then I want to see if this column implies this column. Okay, so again, if this column's false, it doesn't matter what's here, but if this is true, this must also be true, and it's not. And again, if there's falses here, it doesn't matter what's here, they're true. And so because this whole final column is not true, then the argument is invalid. Okay, here's another one. So I have three hypotheses that I'm going to combine together with the AND connector. I'm going to see if they imply P and Q. Okay, so it looks really big, but essentially I've put brackets around each of these to make sure that I do these first, put an AND symbol between them, and then I put some square brackets around all of my hypotheses because I want to see if those together imply my conclusion. Okay, so again, we're going to break it down. First I look and I see, okay, I have P's and Q's, so let's set that up. And then I want to have a column that represents each of these inner brackets. So not P and not Q, I'm doing those first. Then I'm going to find this first bracket, P or Q. Not Q implies not P, so I'm looking at this not Q and not P and seeing if this implies this. And P biconditional Q. And then I'm going to look, here's those three hypotheses that I've created here, right? I've created a column for each of my hypotheses. I'm going to combine and. Now you can do them separate or you can do them all together like I did. What I'm looking is at these three columns, I want them all to be true in order for the final to be true. So this and this must be true. If there's any falses in here, then they're false. Okay. And now I'm going to look, I already have a column for my conclusion here, and I'm going to see if this implies this. So wherever this column is true, this must also be true. So true, true is true. If this is false, it doesn't matter what these are. So they're all true, and therefore the final, because they're all T's, then this argument is valid. Okay, the next level to this is being given statements and having to create the, writing the statement in symbolic logic and then doing the truth table. So the hypothesis is, if I don't tie my shoes, then I trip. If I didn't tie my shoes, does that therefore mean I tripped? Okay, so we're going to write a statement for each hypothesis, and then the conclusion, and then do the truth table. So my two statements is I tied my shoes, I tripped. Okay, I can write all of those three using P and Q. I tied my shoes, I tripped. So the first one is not P. If I don't tie my shoes, then, there's our if then, I trip. Okay, so not P implies Q. I didn't tie my shoes is not P. And I tripped is Q. So there's my 3 statements. I'm then going to write the full statement by combining these with an and implying Q. So here's one hypothesis and another hypothesis, and all together do they imply my conclusion. So I have P's and Q's. I'm going to find my not P, and then I'm going to find my not P implies Q, and combine that. So now I have a column here for not P and a column here for not P implies Q, and I'm looking at where they're both true, which is just this one here. And then I'm going to use this column and see if it implies Q. So wherever this is true, this must also be true. So it doesn't matter if they're false here, true and true is true. False, false is true. So because these are all true, then therefore that argument is valid. Okay, I want you to pause the video here, try this one out, and then start up the video again when you're ready. Okay, so if the example is hard, then I do my homework. So if the example is hard, does that then imply that I didn't do my homework? Okay, so if the example is hard, then I do my homework. The example is not hard. So does that therefore imply that I didn't do my homework? So I have the example is hard and I do my homework. So this, I have an if then, so I'm going to have a conditional statement. So P implies Q. The example is not hard, is going to be not P. And so my conclusion is not Q. So if P implies Q and there's not P, does that mean then not Q? Okay, so P implies Q and not P. Does that imply not Q? Okay. So P and Q, I'm going to find my not P and my not Q. Then I'm going to break it down into these inner brackets. So P implies Q. And then I'm looking at adding this column and this column with an and. So where they're both true. And now that I have this whole first bit, I'm seeing if it implies this column. So where this is true, this must also be true. And because not all are true, then it is an invalid statement. So we're saying here, if it's not P and Q, then that doesn't work for our final statement. So if we look back, we're saying that if the example is not hard, there's a chance that you could have done your homework or not done your homework. Because this only states if the example is hard, then you do your homework. It doesn't state if the example is not hard, did that mean that you didn't do your homework or didn't do your homework. So there is one situation in there where it's not true and therefore it is invalid. Okay, so I want you to think about how you've done over this video and think of the statement, I can construct truth tables for conditional and biconditional statements. If you're super lost, then you're reaching out to me in order to get some help. If you are thinking, okay, well, I'm kind of there, but I need some practice, you're looking at the exercises in Brightspace. And if you're happy, I still suggest doing a couple examples just to make sure that it's locked in your brain, and then you're good to go on to the next lesson.